This video is meant to give you a first glimpse into the art of unit conversion. In this video, I'm going to go over the basics of what units of measurement are and why you would need to convert them, and what that means, really, to convert from one unit of measurement to another. Before I can begin to explain unit conversions, you first need to understand the concept of quantity. What I call a quantity is an amount of something that is measurable. Other sources and textbooks may call it just a measurement. The key thing about a quantity is that it consists of both a number and a unit of measurement. A number by itself is not a quantity because we do not know what that number is measuring or how it is measuring it. For example, 5 is not a quantity unless I tell you what it is 5 of. If it was 5 people or 5 apples or 5 kilometers of distance, then that would mean something. A number itself is an abstract concept that doesn't have any practical meaning, but when you combine a number with a unit of measurement, you get something concrete that can be understood in the real world. A unit of measurement could be an object that is being counted, like people or apples, or a defined measurement of a concept like distance between 2 points. A meter, for example, is a measurement of distance that has a precise definition, and so 20 meters would be that same distance times 20. The meter is a unit measurement, which means it is a basic measurement that can be multiplied by a number to create bigger or smaller measurements. So now that you understand what I mean by quantity, I can actually tell you what a unit conversion is. A unit conversion is the act of changing the unit of measurement in a quantity without changing the amount of the quantity itself. So, for example, imagine I measured the length of a hallway as 20 meters long. I tell my friend that he will have to walk 20 meters to get to the other end of the hallway. But my friend doesn't know what that means, because since he was just a little kid, he always measured distance in feet instead of meters. Really, there's no reason I can't tell my friend what the distance is in feet, even though I didn't measure the hallway in feet initially. To find out what the distance of the hallway is in feet, I could either measure it again using a tape measure with feet marked on it, or I can just do a little mathematical calculation, which is what I'll explain later. Either way, the answer should turn out that the distance of the hallway is 65.6 feet, because that is the same distance as 20 meters. In this case, the number changed from 20 to 65.6, and the units changed from meters to feet. But the actual distance being measured is still the same because it's the same hallway. In the same way, 5 days is a measurement of an amount of time, which is the same amount of time as 432,000 seconds. So if you count out 432,000 seconds on your watch, exactly 5 days will have passed. The only thing changing is the measurement. And now from this you might see one of the main reasons why we do unit conversions is to make a measurement easier to read and understand. It's much easier for me to understand how much time 5 days is versus 432,000 seconds. That's not the kind of measurement we use on a day-to-day basis. Now that I've talked a bit about units and quantities and measurement, I'm going to get into how to actually perform the unit conversion mathematically. The first thing you need to do a unit conversion is a relationship between the unit you are beginning with and the unit you want to convert to. For the previous example involving the length of a hallway, I might have used 1 meter equals 3.28 feet as a relation to convert the hallway measurement from meters to feet. Unit relations are usually easy to find. You may have a table of units that you were given for your course. It may be right at the front of your textbook. Or you can always look them up online, and Google is a great resource for finding unit relations. Most unit relations will be written like the three that are shown here. That is, it will show one of some unit equal to so many of another unit. So 1 meter equals 3.28 feet is the only information you should need in order to convert meters to feet or even feet to meters. Similarly, once we know that 1 kilogram is the same as 2.2 pounds, we can convert a mass from kilograms to pounds or from pounds to kilograms. The next thing after finding a unit relation is to turn that relation into a conversion factor. A conversion factor is a ratio or fraction that is actually equal to 1 that can be multiplied by a quantity to change its unit of measurement. The two conversion factors here both came from the unit relation 1 meter equals 3.28 feet. These fractions are both equal to 1 because the top and the bottom of these fractions are actually the same quantity, and any fraction where the numerator and denominator are the same is always equal to 1. Now I can take any unit relation and make two different conversion factors out of it by putting the left and right sides of the equal sign on the top and the bottom of the fraction in either order. In the previous slide, I had the relation here, 1 meter equals 3.28 feet, and made it into two different conversion factors. You can see in both of these, the numerator and denominator came from the two sides of the relation. Now, at this point, you might be asking yourself, what's the point of all this? Well, you'll need to see a few examples to really understand, and hopefully this slide will help. The point of using conversion factors is that by multiplying by a conversion factor, you can make one unit cancel while leaving another one behind. At the same time, you cannot change the actual quantity you began with because you're really only multiplying by 1. In the example below, we start with 20 meters and multiply by the conversion factor from the previous slide that had meters on the bottom. The reason I want to multiply by something with meters on the bottom is that it will cancel with the meters here in the original amount. After the meters cancel, the only unit left will be feet. Now that I'm confident that by multiplying the units I end up with feet as the only units in the answer, I can multiply the numbers together. 20 times 3.28, which gives the correct amount 65.6 feet. Now, what I actually did in that previous example is listed in these steps. First, I wrote the amount as a fraction. That's why I wrote 20 meters as 20 meters over 1. Any whole number can be written as a fraction over 1. Second, find a relation between the start and finish units. In this case, the start unit was meters. I started with 20 meters. And we wanted to finish with feet, so I used the relation 1 meter equals 3.28 feet. Any relation that had both meters and feet in it could have been used. Third, turn the relation into two conversion factors. You do this by putting the two sides of the relation on the top and bottom of a fraction, the two different ways you can do that. Step 4 is choose which of the two conversion factors will cause the original unit to cancel. That's why I chose 3.28 feet over 1 meter, so that meters would cancel. Step 5, simply multiply it all out by using the usual rules for multiplying fractions. And finally, it's always a good idea to check your answer, and actually I didn't do this step this time, but you'll see me doing this step in the example videos that go along with this topic. Now, for your next step in learning this, I've included some more videos giving examples for more and more complex unit conversion problems, and the first one is actually the same example from this presentation, but you'll see in more detail how I follow all of those steps. As you move along, there will be more and more complex examples involving multiple steps, compound units like kilometers per hour that have two different units involved, and special cases like what to do when you have feet and inches together in the same measurement, such as measuring your height as 6 feet 2 inches tall.